All right, let's talk about this section of rationalizing a denominator. Um, so in our previous lesson, we talked about how to divide radicals, and the key rule to dividing radicals was that our index must be the same in order for us to divide two radicals. Now, the examples that we were working with previously were examples where we were able to take a radical as we are dividing, and either we were able to take, let's say for this example here, we were able to write this radical as one radical instead of two separate radicals, and then the denominator, we were able to divide the denominator into the numerator, and here we have the square root of 2. So we were able to work out this radical. Another question that we were working with, or type of question, we had something maybe the square root of 5 over the square root of 81. And we were able to divide, or let me just go back track for a second. We were able to, well, we're not able to divide 81 into 5, but because our denominator was or is a perfect square or a perfect cube, we were able to take that square root, such as this example, the square root of 81, which is 9, and then we were able to keep the denominator the same. And remember, I said before that in order for fractions to be in simplest form as it relates to radicals, we cannot have radicals in the denominator. Now, in this section, we're going to look at what happens whenever we are not able to take that denominator and divide it into the numerator, or if that denominator is not a perfect square, what we must do. So we're going to do what's called, or use what's called, rationalizing the denominator. Our focus in this section will be just rationalizing the denominator with one term. We can look at two terms, and we'll introduce that in a couple of videos later. But right now, we're going to look at what happens when our denominator is one term. So to rationalize the denominator, number one, you need to multiply both the numerator and denominator by the radical found in the denominator. The reason for this is because when you multiply a square root by itself, the radical will disappear. Number two, multiply both the numerator and the denominator. Remember that you can multiply numbers outside the radical with numbers outside the radical, and numbers inside the radical with numbers inside the radical. So we'll talk about and come back to these instructions as we work out examples. Number three, simplify the radical. And then lastly, number four, reduce the radical if you can. You can only reduce numbers that are outside the radical with other numbers that are outside the radical. So let's go ahead and take a look at the first example. And we're going to be coming back to this sheet here. Now, as we look at let's straighten this up here. As we look at the first question, it says rationalize the denominator and simplify if possible. We have the square root of 7 over the square root of 2. One thing we want to make sure is that we have our question set up as such where we have two separate radicals. We can use one, but I think it's a lot easier to have the question set up as two separate radicals. Now, to rationalize, what we're going to do is create a fraction. And that fraction that we're going to create, okay, notice that I have the square root of a over the square root of a, that the radicals are the same. We're going to create a fraction. And that fraction that we're going to create, we want to make sure that the radical that we use, we want that denominator to be a perfect square or a perfect cube, and or depending on the index, but a perfect nth power. So to do that, let's go back to step 1. It says to rationalize the denominator, you need to multiply both the numerator and denominator by the radical found in the denominator. Okay, so look at the radical that's found in this denominator, which is the square root of 2. That fraction we're going to create will be the square root of 2 because it makes our denominator a perfect square, okay, whenever we multiply. So I'm going to show you that. Now remember, a couple of videos back we talked about what happens whenever you multiply two identical radicals. What you must do, or what takes place, is that our product is going to be a perfect square that we take the square root of, but our end result is going to be the radicand. So let's multiply our numerators, because remember, how do we multiply fractions? A numerator times the numerator over the denominator times the denominator. Okay, so we have here the square root of 7 times the square root of 2 all over the square root of 2 times the square root of 2. Now remember, the rule says if we go back to number 2, it says remember that you can multiply numbers inside the radicals with numbers inside the radicals, and then we can multiply numbers outside the radical with numbers outside the radical. Well, we don't have anything outside just yet. So multiply the square root of 7 and the square root of 2, we have the square root of 14. Then our denominator, we have the square root of 2 times the square root of 2. That's the square root of 4. And remember, no radical in the denominator, so we're taking the square root of 4, which gives us 2. And then our numerator is the square root of 14. Now, once we multiply and simplify the radicals, do not take this 2 and try to divide it into this 14. The only way that you will be able to do that had this 2 been a radical. This 2 is not a radical. So it must be a radical with a radical for you to divide. So we're going to leave our answer as such, the square root of 14 over the square root of 2. Next example. We have here the square root of 4 over the square root of x. So we're going to rationalize our denominator because x cannot divide into 4 evenly. So let's write this as two separate fractions. And now we're going to rationalize, where we're going to create a fraction. Let's create our fraction. And that fraction we're going to create, okay, what we're going to use, remember, is the radical found in the denominator. So the radical that's found here is the square root of x. So remember, numerator times the numerator, denominator times denominator. So we have here the square root of 4 times the square root of x. And in our denominator, we have the square root of x times the square root of x. So before we multiply our numerators together, can we take the square root of 4? Yes, you can. The square root of 4 is 2. That's a perfect square. So we have here in our numerator 2 times the square root of x. So the 2 is going to go on the outside of the radical. We have 2 square root of x. Our denominator, we multiply this together, the square root of x times the square root of x, which is the square root of x squared. And remember, whenever we multiply two identical radicals, it's going to give us the radicand, meaning the x. So the square root of x squared would give us an x. And here again, do not try to cross out the radical x versus the x that's in the denominator. They're two separate expressions. So we're going to keep the radical x as the radical x, and that's the x is under the radical sign, so we don't touch it. But anything outside the radical, if we can reduce it, we will do so. So our solution is 2 square root of x over x.